Let's have a look at power in electric circuits. So we know that power is the change in energy or the work per unit time. And when we were looking at electric potential, we came up with a little equation that the work or the change in energy is equal to Q times delta V. So we can replace that change in energy by Q delta V and put it over time. Now if I associate the Q and the T together, charge per unit time is simply the current by definition, and therefore I get the expression that power is equal to I times delta V. So if I've got an element in a circuit and I know the current going through it and I know the voltage across it, I can calculate how much power that device is using. Here's a little example. We're heating up some water. We've got some sort of, say, electrical current inside the water. We know how much current is flowing. The current is 2.5 amps, and we know that we've got a voltage across here, delta V, equal to 12 volts, or 12 joules per coulomb. And we know the amount of water, our mass, is 100 grams, or 0.1 kilograms. And then we want to heat it up from, let's assume it's at, we got to make an assumption here, we got to get it up to 100 degrees. And let's assume room temperature is 20 degrees, so we've got to change our temperature. Delta T has to be 100 minus 20 in Celsius. Going back to our thermal unit, we learned that Q is equal to mc delta T. Now, in this particular case, the heat is coming by running the heating element for a given period of time. And so the amount of heat energy would equal power times time, the number of joules per second being used times the number of seconds that it's used for. Now our power, we now know, is I delta V. So we end up with this expression, which we can solve for time. We'll have an mc delta T divided by I delta V. We can substitute all the numbers in. So it's 0.1 kilogram. Specific heat of water, 4186. Make sure everything is in SI units. Delta T is at 80 degrees that we're going to raise the temperature by. We've got a 2.5 amp current, and we're placing 12 volts across it. If we carry that out, we get an answer of about 1116 seconds, or say 1120 seconds, which it's about 18 and a half minutes, 18 minutes, 36 seconds. We can also combine our equation for power with Ohm's Law so that we can obtain other expressions for the power. So for instance, we know power is delta V times I. But by Ohm's Law, delta V is equal to I times R. So we get a second expression for power in terms of the current and the resistance of the device that we're talking about. Alternatively, we can say we can start with our expression for power, and we can substitute in the fact that I is equal to delta V over R. That's from Ohm's Law. If we substitute that in for I, we get delta V times another delta V over R to get delta V all squared divided by R. So that gives us now three expressions for power. There's one, there's two, and the third one we had from before. So depending on what information we're given, that will determine which equation we use. Here's a simple question. I'd like you to stop the video, read it over, come up with an answer, and then return to see if you got it right. Okay, so in this problem, all the resistors are identical. And we've talked about equivalent resistance. The resistance of this first one would be 3 times R. The resistance of the second one would be R over 3. And the resistance of the third one would be R plus R over 2, or 1.5 R. So clearly, this one has the biggest resistance, this one has the smallest resistance, and this one's in between. Now, keep in mind that we've got the same voltage across the heater in all three situations. So if we consider this expression for power, power equals delta V squared all over R, and delta V is the same, then whenever we increase the resistance, we're going to decrease the power. Now what we're asked to do is rate this from maximum power to minimum power. So when we have the minimum resistance, we'll get the maximum power. So our most powerful arrangement would be this one here. Our second most powerful arrangement would be this one here, and our third most powerful arrangement would be this one here. Second question. Once again, stop the video, read it over, try it out, and then come back for the answer. I'm going to draw the circuit very quickly just to illustrate something. So in the original case, we had a 12 ohm resistor and a battery across that resistor. And then in the new situation, we put a smaller resistor here. But we keep the same voltage. Now, I've got two equations for power that involve the resistance. I've got delta V squared over R, and I've got power equals I squared R. Now, I don't want to use the I squared R because I is different. This is an I1, this is I2. I is different in those two circuits. But the voltage is the same in both circuits. So I want to use this expression here. And originally, I'll call it P old, I had delta V squared divided by 12. In the new situation, I've got delta V squared divided by 3. Now, if I multiply the new one by 4 over 4, I'm going to get delta V squared divided by 12 times 4. In other words, this is 4 times my original power. And so my answer here should be D. Okay, another question. So once again, I'd like you to stop the video, read it over, try it yourself, and then come back for the answer. All these resistors are the same. So the equivalent resistance in this case would be 2R. The equivalent resistance in this case would be R over 2. So we're looking for this ratio Px to Py, the power in X divided by the power in Y. The power in X will be given by the voltage across the circuit, so that's really just the battery voltage. That'll get squared divided by the equivalent resistance, which is going to be the R over 2. And then we've got to divide that by Py. Py, of course, it's the same battery, so it's still delta V squared over this network of resistors. Our equivalent resistance in this case, though, is 2R. So now if we invert and multiply, the delta V's are certainly going to cancel out, and we'll get 2 divided by R times 2R, which is going to give an answer of 4. So circuit X is going to use up more power by a factor of 4, and the correct answer is D. And that's all for today, folks. Thank you very much.